We're down here.
Wait, we're over here near the logo.
They put us on the logo. They hit us with a shrink ray.
Yeah, you remember those bad people from all that time ago?
We took our show back, and then they hit us with a shrink ray. We're so small.
We're all tiny now.
Wait, I have an idea.
Okay, what's your idea?
I have an idea.
What's your idea?
I'm gonna think really hard.
Okay.
All right, and then we're gonna get bigger. All right, so I'm gonna.
Doing my density. How's it going?
I'm not small anymore.
No, you're still small.
Oh.
How's it going, everybody?
How's it going? Hello and welcome to your weekly dose of mayhem, the only show with variable-sized host.
Yeah, I think you actually thought a little bit too hard. We're larger than usual.
Are we?
Yeah, we're in widescreen now.
Do you want me to get back? We can get. I can try again.
No, I think we're.
Do you want to get small? Let's get small.
No, we're gonna get small.
We're so small. Let's get big. We're so big.
All right. Anyways, not only are we big, we're also back. And do you want to tell the people why we're back?
It was Thanksgiving break last week, so we didn't do it.
Yes.
Did we?
But why are we so back?
Oh.
Like, why are we so back?
So guess what came in over Thanksgiving break?
In the mail.
In the mail. It came in many a box.
Mm-hmm.
It was very heavy.
Yep.
This is a guessing game. It was very heavy, right? It's got 3 axes of movement.
Okay, so I'm thinking 3D printer.
No, it's like that, but opposite.
2D printer? No, not opposite. Okay.
Opposite.
Another filament shredder.
No. It shreds something.
It shreds.
Kind of.
It cuts. Okay.
Yeah.
3 axis. It's the router.
It's the router.
It's the router. The router came. We set it up. It's in the place now.
It's in the
next
shop.
to the old one.
And it mostly works.
It works totally.
It does?
Yeah. Yeah, we routed.
Did we get the FreeCAD thing figured out?
Yes.
What processor to use?
Yeah, Marlin.
Oh, so we were right. Okay.
Yeah.
Yeah, so we set up the new router and we had some issues with it. We didn't know what processors to use, and then apparently we figured that out now. So Hamid was basically hand processing G-code for a second there. We also tried to use the new Onshape cam software, and that doesn't have Marlin, so it doesn't work.
Which is weird. Because Marlin is like the everything G-code. It's like the
It's like
G-code.
the one. It's like.
Yeah.
It's like G-code. It's like the debut album of G-code.
So it's just disingenuous to not support the G-code and support like every other CNC machining company's version of G-code.
Yeah, it's like if they didn't export in G-code.
It's like if it was an album that just had remixes.
Yeah. Yeah. No, you're right though.
Yeah.
No, you're right.
So that's when I have to hand process them, because the closest thing that I could get in terms of the current Onshape cam presets is like a Stepcraft machine or something that almost has regular G-code, but it just adds dots to it for some reason. So if I remove the dots, it works. But I also have to turn the Z-axis upside down. But if I just use FreeCAD, then it works basically.
Yeah. Well, I mean, the downside is then you have to use FreeCAD.
It's the best FreeCAD software.
Can you name another one?
All of them, if you try hard enough and know where to look.
Fair. So yes, the new router is here. It mostly works. We like it a lot. It's very quiet.
Yes.
We've cut polycarb in varying thicknesses, and we've cut wood. Mm-hmm. And it's very precise. It's very good. It's the Onefinity Journeyman.
Yeah, with the Redline controller.
And we added the Stiffy, which is an extra cross brace on the X-axis.
Yep.
Which makes it so that you can cut thicker and more hardy material. Steel.
Yeah.
We also
have
all
of our robots out of steel now.
We also bought the XYZ Origin Probe.
Yes.
So that's what we got it set up if you are looking for a new router. How much was the total when it came out to it?
I don't remember.
Like 5,000 or 6,000, I think.
Something like that.
Something like that.
We also got the socket, which
the
is
socket.
A brushed sort of like vacuum attachment on the spindle, so it just sucks up all of the debris.
That's the one thing we haven't gotten working yet. We think it's too tall for the bits that we use.
Yeah, we're crashing this machine with that on, which is weird. Not exactly sure why, but we're gonna look into that.
It's probably just
something to do with the bristles.
Somehow, moving it up.
Yeah. But the Z probe or the XYZ probe is very cool. It's way better than what we had before, because what
Which was
we
just
had before
guessing.
was, jog it over here, and then just kind of like tap the material and kind of like bend it, and it's like, oh, that's probably 0, and then we would get like completely different things every time. The Z Pro, like the machine is so accurate in its movement that you
that's
just
cool.
put the Z Probe.
It's just like a little metal
It's like
box.
a little metal thing.
Yeah.
And then you connect like a magnetic little
Here.
thing to the
This is the Z Probe.
Yeah.
I'm
router. So the spindle has like a little clip on it, and it's magnetic, and then this thing also has a clip on it, and so it just checks for continuity between them. So what it does is, the first thing it does is, like, I start it here, it goes, right, and then that's how it figures out the X, and it goes, and that's how it figures out the Y, and then it goes, and then it figures out the Z.
And remember, it's not screwed down or anything, so it's just so
it's
precise.
Just so gentle
It
with how it
taps
touches.
it and doesn't move it.
It just taps it, never moves it.
That doesn't move it. It's
As soon as
crazy.
it gets continuity, it stops. It's so cool. And then if you're like in the middle of stock and you want to just make like a little part in the middle of it instead of doing it at the corner, you flip it around,
And you can
and then
use
you
just the
do the
Z.
Z, and it just goes, and then you're done.
And then you can zero it how you normally would.
Yeah, with the X and Y. The X and Y you could just guess, because that's not as precise.
Yeah,
So
that was-
it's very cool, very fast. And if you're doing something where you're like machining on a whole stock at once, like it's one stock, one G code, then you can zero it at the corner of the stock, have that in your CAM software, and then just run it.
You could route an entire robot in one setting if you wanted to.
Yeah. And
Assuming it all fed on one piece of stock, probably covered,
you could,
whatever.
yes, I think so. I think we should experiment once we've got a little bit more familiar with the machine. I think we should try making a whole bunch of CAM in on one stock and just running it, because I think that would be a lot better than this part's done, put them on,
Yeah.
etc.
So yeah, that's the router part of the title.
Yep.
Here's the robot part of the title.
Yep.
Not many updates with this guy. You can't really see it, but maybe if I put my hand behind it, you can.
There's a protractor.
There's a protractor on it.
attached to the thing for angles. That must sound
Awful.
amazing. That
Yeah.
sounds great.
So it's got a protractor on it so that we can get angles.
Yeah, so what they did is they put a protractor on it, and then we basically you run the servos to different positions, like 0.1, 0.2, maybe even 0.3, and then you basically
the hood's got the collar's got a little line on it.
So
now,
you
can
check
set the measure of the
you
angle.
check where the angle is compared to the line, and then you plot them, and you get a little graph, and the graph looks like this.
So that's actually not the full graph. That's only got like 4 data points on it. But
I think that's all they did. It's,
Oh, really?
It's a linear relationship. It's rotation to rotation.
yeah. So on the Y is angle, right?
Yes.
And on the,
On the
X is
X
how far the ball went.
No, this is just a regression for the axon tuning. So we basically
it's the axon's position. Oh, cool.
Yeah.
Cool.
So that's how we get a good coefficient for that without having to like look in the CAD and mess with the gears and whatever. And we do the same thing with all of the other stuff to do trajectory math and everything, and it's just a whole bunch of regressions all the way down. It's all the way up and all the way down. It's a whole bunch of regressions. So we're gonna go from this to we're gonna go from angle to initial velocity as a vector, and then we're going to use that to calculate the throw, and then we're going to say if I want to put the ball into this area at this angle, what is my initial velocity and what's my initial angle? So we have 2 inputs and 2 outputs, and that's all math, good math, and we're gonna shoot fast because of that.
And we're gonna shoot 3 at a time, and we're going to win everything.
We're going to win the world, not worlds, the world.
The world. We're going
be,
to
like emperors and like kings and presidents of the world.
And no one will be able to take our podcast away from us ever again.
And also, we will ban car-based commuting, and there will just be trains.
Trains everywhere.
Trains everywhere.
And free cake on
everything.
free cake on Tuesdays.
Free.
but only on Tuesdays.
Only on Tuesday. Free day. Tuesday,
Free day.
Yeah.
Every week.
Mhm.
Anyway, Emily, you can have the robot back. So yeah, that's the update on the green bot and the white bot, which is over on the table, and we're just gonna talk about it. The white bot is almost done, being made out of wood. So I'm not sure if they're gonna route it out of polycarbonate or not, but now that we have the new router, that is a possibility.
Yeah. We still also haven't routed aluminum yet.
True that.
So we're gonna do that next probably. So do we want to talk about the hey,
we
I want
haven't
that.
done that yet.
Hey.
Yeah, put it. Well, here, slide
trying
it
to sabotage
over.
our show
Slide it
again.
over. Your turn on.
Oh, okay. We're doing this.
We're doing this now.
Hold on. I have to set up the thing.
I don't know. I'm gonna check right now.
Oh yeah, hide. Whoa. Okay.
Wait a minute.
Wait, he's got to change his
Wait
crop.
a minute. Oh, the keyboard. Okay, there we go.
There we go. Now we got table. Show us some
That's
table.
the table.
Emily made this.
This is a hovercraft. Oh, it's the mouse.
There's a hovercraft. There's a hovercraft on the table.
They can't see it because of the hold on.
Is the monitor in the way?
Hold on. Is that better? You just gonna hold it? All right.
Okay.
I guess we'll run it again. It's a hovercraft.
There's a hovercraft.
Yeah. Look at that. Up and down. Yeah, there you go. Yeah. That's all. It hovers.
It crafts. Here, send it. I caught it.
It's great.
There's a hovercraft.
It's great. It's a craft. It hovers. That's a hovercraft.
It hovers and it crafts.
Yeah.
So Emily made this for Science Olympiad, and we thought we would show it off because it's pink and it's cool. And it's a hovercraft.
Yep.
It's made out of pink foam and some sort of material on the bottom. I don't know what material it is. Some sort of balloon material on the bottom, and it's got these fans on it. Ow, that was sharp. So yeah, you can have your hovercraft back too. Wait here, I'll send it over to you. Turn on, bro. Oh, gosh. It's yeah. Okay. Wait, what are you doing?
Hold on. We gotta get the table out the way. There we go.
And once again, our bodies have been cut off by the ever-encroaching void of graduation.
The bar.
Anyway, I guess the last topic of discussion is, Ahmed, what did we do last night until 7?
Last night until 7? Mm-hmm. We party rocked, I reckon.
But how?
In the house tonight.
FSC, we were party rocking. FSC was party rocking.
In the house tonight.
In this house.
And you better believe everybody was having a good time.
Yeah, so FSC had its second 2 preseason meetings. On the first one, everyone went around and tried a little bit of everything. We had a presentation from the awards sub-team talking about what they do. And a couple of the rookies joined that, and a couple of the returning members switched over that, which is pretty cool. And then we did a little mechanical thing, and I showed an old game, and we split it up by grade, and everybody designed a robot from everyone designed a robot to play that game. The baby car made a surprising comeback. Do you remember that meme?
Let's go.
So everyone did that, and then we did a little programming activity, and everyone had to make a little maze in Scratch. They also had to figure out how they would program their robot that they drew for Power Up was the game we did.
And Nate's Maze is going to make a special appearance on the show right now. What's your username?
I'm gonna say this out loud on air.
Well,
yeah. So my old Scratch username is Downloading Empire, all caps.
Oh, it is. I remember. Yeah.
Yeah.
That's gonna look.
I didn't make it public.
Okay.
Oh, so you can't see it.
Could have said that a little bit earlier.
Yeah, I only realized it once you started typing. Well, if you want to go look at my old Scratch games from middle school, there you go. Just go and put that in Scratch.
_Empire. Okay.
You can play Duckman Jump.
Mm-hmm.
And 7 Nights at Steve's.
Seven Nights at Steve's is the best game I've ever played.
It only has 1 night because I didn't program the other 7 because I couldn't be bothered. Anyway, so yeah, we did.
The second of
And then the second meeting, we did. Just gonna unscrew it out of this mic now. The second meeting, we signed everyone up on First Inspires. We made an Onshape classroom, and we changed how we are organizing an Onshape a little bit, which is better. So we got everyone into the Onshape classroom. That also gave everyone access to the CAM software, which we aren't using yet because I think Onshape. We emailed Onshape, and I think they said they're coming out with capabilities for Merlin.
Did we get that email?
I don't know. Just what Josh said.
Josh! Did Onshape say they're adding Marlin?
Okay, so I guess Josh is just making stuff up now.
I said they're going to add more features in the future.
Oh,
I didn't say which ones. I don't know which ones.
no, I hope it's Merlin because their software looked pretty cool.
Yeah.
I didn't actually get the chance to play with it. And so we got everyone signed up for that. Then we split up by a sub-team. And Mechanical, we started work on a preseason shooter. And what that is was our programmers have little templates and code for like a bunch of subsystems. They got tank and they got swerve, they got elevators, they got arms, they got intakes, they got outtakes, but they don't got a shooter. So that's what we're working on building during the preseason so that in the first couple weeks of the actual season they can build up a little template for themselves, which is a shooter. So that's what we started working on. We did some compression testing. We're shooting the 2020 foam bars. So we did some fun compressing testing. So that's what we spent our time on. What did programming do?
Well, so you remember how 13 seconds ago you said that the programmers have a whole bunch of subsystems to play with? Well, this is the thing, right?
Did
In
I lie?
FRC, programming just the standard robot is pretty easy because the libraries do most of the grunt work for you. So you just have to write a little bit of boilerplate and a little bit of like, yeah, I want that motor to be that motor. And then the rest is all done for you, basically. All of the PID control, all of the scheduling, it's all done for you. So we just want to make it easier for people to get started with an FRC robot on our programming team. And I mean, it's public on GitHub, so anyone. Really. So the first part of the season for us programmers is going to be writing some sample, basically just a whole sample robot that has an intake slash outtake, elevator slash ladderator, indexer, all of these components that are like functionally similar. They have the same like number of motors and sensors and everything, and then they can be used for whatever. So like the intake slash outtake code is just like one motor and one sensor to check if there's a gain piece in its grasp. Like shooter code would just be one motor, but it has velocity PID, so you can like tune the flywheel. A elevator code would be one motor, but you have an encoder on it, and you can make it go to a set position. And yeah, so very bare bones like sample code in this repository. And then what we hope will happen when us seniors are gone is that the younger programming team members will just be able to take from that and also from the previous year's robots and be able to go, I know how to put this together, and then they can focus on cooler things like path planning or AI or
Vision.
that is also AI.
Well, very okay.
All of the AI stuff. I want to do a lot of AI this year. I'm just gonna say what me and James were thinking of, so that maybe it motivates us to actually get it done. We were thinking of doing something with NVIDIA's Isaac Sim, which is a real, actual robotics AI development platform, which like Amazon uses and like other big warehouse robot companies use. And basically what we think we can maybe accomplish is, instead of plugging all of the cameras that we have on the robot into like AprilTag coprocessors or Vision coprocessors, then getting the data and then handling it manually, you take the Vision data, you put it into an AI model, and you tell that AI model the outputs of the robot, and then you say, "Hey robot, can you see? Now look at what you see and then do." And the entire rest of it is done by the AI. And you might
So
be asking,
actually, just building like, taking the human
Yep.
out of the driving.
Yeah, and our end goal for that, which I mean probably isn't going to happen, because I don't even know if James is interested anymore. But the end goal would be a robot that would just drive, and the drive team could just like bring up like 2 armchairs to the driver station and just have like a cup of tea.
How would the robot be making decisions about what to do in the match?
Well, that's the thing is I hope that one of the questions that you have is how would the robot figure out what to do in the match, right? And the answer to that is reinforcement learning, and a lot of reinforcement and a lot of time. Right? You have to basically say, robot, this is the field, this is what you're seeing, and then you basically just have to wait for it to score something, and then you say, that's a point, good job. And you have to wait for it to avoid another robot, and you say, that's a point, good job, and it learns from that reinforcement. And now I know what you're thinking. You're thinking, that's going to take a lot of time, and we don't even have a field. Well, let me tell you. You can put a field into the sim. That's the sim in Isaac Sim. It's the simulator. So you just make 100 fields and put 100 robots on each field. Or you put, and then you just have them fight it out, basically, until one of them wins and does the best, scores the most points.
What about differing strategies based off what your partners are doing and what the coach decides before the match?
Well, so
how does the robot cope with that?
So
I've never heard about this idea before, so this is genuine questions.
Yeah, this is. I mean, I made it a secret with James.
Is this a thing that you guys wouldn't tell me?
Yeah, this is
okay. This is a thing.
Yeah,
okay.
And I'm realizing now that's kind of dumb. Like I'm just gonna say it. So in terms of strategy, I mean, the robot hopefully will have the ability to like sort of strategize as it's playing, like in the actual matches by seeing what other robots are doing. And what we could do to inject some of that into the simulation is by playing a game like basically controlling an actual robot or giving it some log data and saying, this is the AI robot, this is the human robot. Make the AI fight the human, right? Sort of like when you play chess against the computer.
Yeah.
Right. So we could do something like that, and we could say, okay, these are like 15 different matches of 15 different types of robot strategy, and then it'll fight them all just to basically be able to handle all of them in a real-world situation. All of this is very hypothetical, and it's almost certainly not going to happen, but...
Seems very hard.
Yeah.
It's cool.
Yeah. I mean, also, it's been done before, so all of the tooling is here.
Not in first, though, right?
Not in first.
Yeah.
Absolutely not. But here's the thing. You know how you have to be under a certain budget for each COTS part you buy? What is it?
$800.
$800? The Jetson...
Maybe it's 900.
Yeah, the Jetson, the computer that handles like the NVIDIA processing is just under that. So technically, after we train a model, we could put it on the robot. But it would cost a lot of money and probably not work. So it'll probably just be a little side experiment.
Well, it's a cool side experiment nonetheless, and I'm excited to see how it happens. I doubt it will go on the robot this year.
Yeah, no. But we could, as long as we write everything down, hopefully someone might be interested in the future. And then, AI is always changing. So hopefully it'll be even easier in the future. Maybe it'll even become standard for FRC. That would be
That would be cool.
Has AI stuff already. They have like a full-on AI competition.
Yeah.
So,
Could be cool.
Yeah.
Anyway.
So, hey, did you watch The Thinking Game?
No, I didn't.
You should watch The Thinking Game. Then you'll know more about what I'm talking about.
I watched the CGP Grey video on how AIs learn.
That's great. Everybody
So
here
I know
should
that.
watch The Thinking Game. It's a great documentary by Google DeepMind. It's free on YouTube. For free. 1 hour. It's really good. Very fun.
Know what else is free on YouTube? youtube.com/@electricmayhemrobotics.
You know what else is free but not on YouTube?
FTCOpenLines.org.
That's right. And you know what about that is also on YouTube?
The FTC Open Line show.
Dude, he's getting all of them. Oh my god. All right. So yeah,
Anyway.
that was FRC. That was my rambling about how I want to do something that's never going to happen.
And that's our time.
That's our time.
So if you got nothing else.
How long were you wearing that for?
Oh, I've been wearing this for probably 5 to 10 minutes right now.
Wow.
Did you just notice?
Good night, everybody.
Good night, everybody. I'm Mr. See-Through, and you can't see me anymore.
I just won this trophy.
Oh, this is what we get for being the best podcast?
This is amazing.
Bye-bye.
Well,